Frol, thank you so much for being here and taking the time to talk to us about the RPC interface for Near Protocol. This has been a kind of one of these very mysterious parts of the platform. We don't spend a lot of time talking about it. We don't have a lot of examples where we talk about this. Normally, we're interfacing with the RPC through Near CLI or Near API.js. And so obviously for developers that want to build either new APIs, new wrappers, or they want to directly communicate with the RPC API, this will be invaluable for them. And what we've agreed to do for this is we have a list of questions prepared to kind of shape the conversation, but maybe not limit it. And so we'll just start answering those questions. You will be speaking as if to a developer with 5-10 years experience, and I will slow you down if I feel like maybe something I don't understand, or too many other people won't understand. And this way we'll just move through the conversation, and we can see where we land with it.
Yeah, sure. It's great, Sharif. Thanks for intro.
Sure.
I definitely see that we usually don't notice how RPC is used, but as you said, it's very core piece of infrastructure that is used across the board, and that's why it feels like it's still very important to know exactly what it is capable of. So let's start.
Let's talk about this kind of one of the questions that we have in the document here that we're tracking. How can I find out which contracts are deployed? How can I find out which contracts are deployed?
Yeah. So first of all, I just want to briefly mention that contracts are the accounts in Near that has WASM code uploaded to the network. So whenever you talk about the contracts, you usually need to look into account section, and it is sharing the same account ID, all that information. So every contract has account information, though not every account has the code deployed to it. So keep that in mind. So whenever we are talking about contracts, you can always make a view account call to JSON RPC. This is a query you need to issue. You essentially specify that your request type is view account, specify the time frame that you're interested in. Usually, to be on the safe side of things, you prefer to be in the pull the latest data that is final. You can read more about other options like other finality states or how to specify the specific block, hash, or height to query the historical data. But with this example, you can see how to query the latest. Here's the example where we use testnet account near cat. And the example response would be one that contained the account balance. It's a liquid balance. Locked is the balance that the account can have natively staked. And the most important part here is a code hash. So code hash is essentially a checksum of the uploaded contract in base 58 encoding. It is unusual, and we essentially consider to provide more expected hex encoded hashes, but overall right now it is base 58. And when you see all ones here, it essentially means that there is no code. It is 32 0 bytes, which are, when you encode them in base 58, gives us this representation. So this is an indicator that there is nothing or no code deployed to this account. Other info here, just for FYI, is that the storage usage is the amount of bytes this account reserves for itself. When you don't have code deployed to the account, this number is only used to store the amounts, the account ID, and that's pretty much it. And just heads up here as well, this field is deprecated, soft deprecated. We prefer to keep backwards compatible, that's why it's not deleted. And this information is the one that you could refer to as a reference when this data, when this response was essentially generated, because you have independent nodes, peer-to-peer. Some nodes could be outdated, and you can essentially end up querying final latest state for that node, but you can't be sure that it's up to date. This reference here serves you the purpose to be on the safe page. You can estimate how outdated the data is, or it is not. So
okay, so it sounds like there's a couple of things that you've covered here. So the first thing that you said is accounts and contracts have this one-to-one relationship. Near has accounts that have friendly names, human readable names. You may or may not deploy a contract to an account. If there's no contract deployed to an account, code hashes all once. That's the default. When you deploy a contract to an account, then the code hash will change to be something like the checksum or the checksum of the contract binary code, actually. So that's how you know. And so that it's like a fingerprint for the contract. If two accounts have the same code hash, you know they have the same contract. That's kind of the part there. There's some of this metadata that some people may recognize this when they're using near CLI. They basically get this metadata back, this response back about the account. It's basically a pass-through from the RPC API. And then the last thing that you said about block height and block hash is that because we're asking for finality final, the block height and block hash of this data, we can assume, and this is a question I'm asking you, we can assume this is that any node which is tracking this shard, any node in the network, and you interrogate this block height or this block hash, has basically come to consensus about this account state. Is that what you're saying?
Yeah.
Because of that finality. Yeah.
Yeah, and also when the network progresses, the new changes could be made to the account, but certain node could fall out of sync, and that's why it's very important to not blindly rely on whenever I ask for final state, I can just ignore the fact that the data could be outdated. You're saying
you shouldn't just ignore the data. You should actually verify that this is a current block height or a very recent block height.
If you care about the latest, you need to double check that you are on the same page with the tip of the network.
So that's news to me, actually. So are you saying that there is a scenario where the query can be finality final, and somehow the RPC interface that I'm interrogating might get a response from an outdated node?
Yeah. It could be.
And then what would be your recommendation then? The block height that I get back, I ask the network again how far it is from the current tip, something like that?
Yeah, you would probably want to check the status very first, probably the very first.
Yeah, so it's some status endpoint, and we can.
Yeah. So essentially, you issue a method with empty parameters status, and you will receive all the useful data from the node. What you want to learn is the latest block height, and make sure that the latest block time is somewhat recent according to your expectations. You can also check if the node is syncing. If it's false, it means that the node is reasonably up to date. It could be just a few blocks behind, just because of the latency across the network. But if it's not too outdated, this flag will be false, and this will help you to understand that this latest blockade is essentially quite recent. You compare this latest blockade with the one that you receive from the query account response, and this way you can reason about the freshness of the data.
Okay, so this is I think a key point that you're making. Let me see if I can restate it. With any one of these RPC endpoints, not just this first one that we happen to start with, the block height is included in the response typically, and I would assume it's just sort of part of the response. I actually haven't checked if they all reply with the block height, but it seems reasonable. So even if the finality is set to final, because there's other parameters or other values for the parameter of finality there, right? So if I assume finality is set to final, when I make my query, there is a chance, I don't know if it's a good chance or not, but a chance that I'm getting back the most recent data. But there's also a non-zero chance that the data is actually outdated. And so there's a requirement here that I query again to maybe a more general endpoint, the status endpoint you're saying. And from this status endpoint, make sure that the node is not syncing, the reply in the status. Otherwise, if it's syncing, it also might be out of date. So syncing should be false in that reply. And then compare the block heights and maybe the timestamps of the status to get a sense of actually how recent this data is. So this is how you would think about it when you're pulling this data back, right? And we know that blocks are produced once a second. And so if it's more than a few seconds out of sync, it's entirely possible that something else has happened on that account to change its state at that point. A new contract could have been deployed, or the amount could have changed, or whatever, right?
Yep. I just want to clarify, if the account is not under heavy updates, it does not get a lot of traffic. Usually, the changes would be invisible, and like it's rare when something would go wrong. I just wanted to make sure that we are understanding that the implications of why it is here, why it could be useful, and what it could indicate that something is not working fine. So you could imagine the situation when you have a system built that is constantly querying the status page in background and saves this the latest is this. You just have it in your program, and the rest of the program is querying various endpoints, like viewing accounts, viewing some other data. And it, instead of just requerying all the time, like I do one query and then make a query to status, I would suggest probably to have it in status checks in background, sitting, checking what is the latest. And then you can, whenever you query the view account, you can immediately write in your program, compare with the latest. Okay, I recently requested status page, and now I just see that, well, this blockade is reasonably up to date. So
yeah, I think that makes perfect sense the way you just described it. So the way I was suggesting it was inefficient, that you would sort of have this query every time. In the end, you know for a fact, because of the nature of this system, and as blocks progress, nodes are going to come to consensus. When you query from the RPC, you may be querying a node that's a little bit out of date, or it doesn't have the latest sort of information. And so why not just have this heartbeat constantly monitoring the state of the network, right? And just have this continually progressing, and just verify your queries against this cached sort of tracer of the tip of the network that you've made, right? That makes perfect sense. Yeah.
Yeah. So getting back to the original question, how do we query the contract, and what exactly do you want to learn about the contract? What was the original question?
So the way I was thinking about this is, if I want to ask a question, how do I know which contract is deployed on a specific account? I might be, for example, working against a staking pool, about to send my money, to stake my money in this tokens in this staking pool, and I want to know, like, is it actually the correct version of this thing? Is it the one that I expect, or maybe it's a DAO that I'm working with, and I want to make sure that it's the DAO that that I can see locally, the source code that I can see locally is actually deployed in this particular account before I, send a proposal to the DAO. So this kind of reasoning about the integrity of the contract that's been deployed on chain, being able to verify that it's what I'm looking at in the source code that I have locally. I want to sort of factor out the idea of like deterministic compiles. Like if you compile the contract on your machine or I compile it on my machine, it produces the same code hash. I'm not sure if that's currently even the case, but let's say that were the case, then the question, it seems like it would be one of the most common questions actually that you would ask about a system like this. Is the code that's currently running the code that I'm looking at? And so that's where this question comes from. But that's the single account question. We can expand it and say, do these two accounts have the same contract on them? And the answer is easy. If they share the same code hash, the answer is yes, and you're done at that point. There's nothing more complicated to think about. And if I ask, for example, which accounts have this contract on them across all accounts in the system, the RPC interface maybe isn't the right way to ask that, right? You were saying?
Yeah. Let me answer one by one. So there is still a lot of ongoing work in terms of like defining the interfaces of the contracts or learning what exactly is the code. So I will start attacking this problem from the technical point of view, what is currently, what is the state. So currently you can upload any WASM code to the network. This means that you can produce this WASM code from, like, even write it down manually. You can use WASM text format to write down the assembly code and compile it to WASM binary and upload it. You don't need to use SDKs, you don't need to use Rust or assembly script. You can use C, C++, even raw format, raw assembly, WebAssembly. And ultimately, you will just upload a binary blob to the storage, and the network will happily accept it and store it. Your storage usage will increase, your code hash will be updated, and that's pretty much it. There is no hard requirements as to provide certain methods. You can upload the code which has no methods. You can upload the code which does not compile. It's not a valid WASM binary. You still can upload it. You will only notice that something is going wrong when you try to call it, and you will receive certain errors like, okay, it's not a valid binary, it's an image. Like it was like you can upload JPEG or PNG image there. It's useless, but you could.
Your point is it doesn't even have to be a WASM
block. Exactly.
Yeah.
You won't be able to execute the code if there is no correct code in it, and this turns to be a very good flexibility from one point of view, but it turns out to be quite problematic for those who really expect the code to be there and they want to verify that the code is what they expect to be. So currently there is no way to from JSON RPC to learn what code is doing and what it is there. What we tried to build is essentially, so as you mentioned, there is a concept of reproducible builds. Whenever you compile on any computer out there, the same code will produce the same binary. This is implemented for Rust SDK. We have Docker image with all the environment fixed to the point that if you download the same Docker file, you will try to compile the same code, you will receive the same binary. So it is reproducible now. But our idea was to keep track of our core contracts. When we recompile them, we record that this binary has this code hash, and this way you could verify that, look up essentially what this code hash is referring to, which contract is it. There is currently no implementation; it's still under construction. But this is a reasonable way to think about this problem. And another approach to this problem is to attack it from a different angle. Instead of defining exactly this is a binary and this binary represents that code, you could build into your code a special method which you can query. So for example, then the method would be like get contract info. So it would be sitting right in the contract. It would be just a function. And given the nature of near protocol, you can make a view function call. They are free of charge. You don't need to pay for them. It's not a transaction. You cannot do any mutation inside the function you are calling, but you can return certain values. You can read, and in this particular case that I'm trying to explain, you can return always a constant set of fields, saying, well, I'm a contract lockup. I'm a lockup contract. I have a version 1.0. I have these methods. I comply with this NAP standard, and that way you could build a convention to provide your contracts out there. If we build a convention and have such a method on every contract, that would be the way to get some idea what the contract is capable of doing. All of this is hypothetical, like we are still trying to shape it together, but hopefully somebody in the community could be also interested in this problem, and we can arrive to a generic solution. We have some discussions, and there are different requirements. People want different things. That's why I didn't really progress into a final decision. And if you want to participate, you can still chip in. There are NAP discussions. I guess we will link to the discussions in the video notes.
Yeah, and then just to kind of summarize what you're saying is, so we were talking about the contract that is deployed to an account and asking the question, how do I know what contract is deployed to an account? And we were saying, if we have deterministic compiles, which we do in the Docker image that is standardized, I can compile the code on this Docker image and expect to see a consistent output no matter what the platform is where this image is running. I get the same code hash. I know that this source code is deployed to this contract. You went on then to say, maybe an improvement or an enhancement of this answering this question would be to actually discover what code is running or what the contract is. You could interrogate the account and ask, by sending a function call here as you have on the screen, tell me about yourself, some sort of a reflection API, or maybe it emits an API,
exactly.
abstract binary interface, an ABI, or some JSON blob that represents the interface somehow, or maybe, as you said, even simply just a string message that represents the specification that it adheres to, or the URL of the NEP that it adheres to. Anything like that, it's still not quite clear what the best way to implement something like that is. There's ongoing discussions, but there's no at this point there's no wrong way to implement that. So if people want to allow their contracts to be discoverable, to be something that the developers can interrogate in the community, just add a method and document it. If you query this method, my contract will tell you all about itself, right? Something like that.
Yeah. So my current take usually is that I try to. So I have some idea what the contract could be. For example, I have an idea that the contract could be a lockup contract. I would open it on our repo, scroll down to interfaces section, and come on. Yeah, so here is a list of like owner methods. They usually are protected for owner usage, staking methods. And I'm scrolling down to view methods. So anything that starts with get is usually the case. I'm just trying to make those view calls. So I make this free of charge call to the method, to certain methods, and try to understand what the contract that is deployed there.
So you're saying yet another method of discovering the contract that is deployed on an account.
Yeah. So it's all
kind of just experiment with the interface to see if it matches the documented interface. Yeah, that makes sense.
Yeah. So it's sort of a workaround right now, given that we don't have a special way to create the exactly what the contract is, and this way you can build your knowledge just poking around. You can also query in Explorer. You can open the account, and
this might be a bit confusing, but the account named near is actually has the lockup account, the lockup contract deployed to it.
It's not a lockup. It's a link drop.
The link drop contract. Yeah, sorry.
Yeah. So here's a link drop contract.
Yeah.
It's a separate repo. By the way, it's not very well documented in terms of I just described that you could look up. So let's use another way. Just to I will walk you through. I usually open the librs implementation. I scroll down to find the main contract implementation. I ignore those that are payable because they are not going to work very well for me. You can still actually call this method as a view method. It will just fail. It will say that, well, it does not work in a view call context, but it still will give you an idea that the method is essentially there. So the method exists. But you can scroll down and see, well, there is a get key balance, for example, method. You can call it. It's definitely not changing the state, and that's why view call will succeed.
Yeah, and in Rust you can tell it's a view call because it's not mutable self.
Exactly.
Right? The self is either borrowed or owned by the method, right? Either there's an ampersand or no ampersand, right? Something like that.
Yep. Yeah. So another way would be to just search for the self.
It's always borrowed. Yeah. Mm-hmm.
Yeah. Or as I said before, you can try with get. Usually by convention, we also prefix them with get. Yeah, and as you mentioned, near account is essentially a contract with this link drop on it. And there are plenty of useful methods like create account and claim. And you can see that there are quite a few create account calls, and there is send call. So by looking into Explorer, you can also build some expectations what this contract could be. If it's not answering your question, in programmatic way, but it is a way to just at least discover what it is.
Yeah, sure. If it quacks like a duck, it's a duck. If it adheres to the interface, then it's close enough to that contract. It may not be exactly that contract. Yeah. Mm-hmm. Okay, so I think that makes sense. I don't know if we've covered sort of the other piece of this. So right now we've covered how do I discover something meaningful about the contract deployed to an account, and it's the code hash is the answer. That's the fingerprint, the hash of the binary of the contract after it's been compiled. So that's useful. Yep. If I want to compare two accounts to see if they have the same contract, I just compare the code hash. There's other things that we've discussed here in terms of how I can check the interface, test it, poke at it to see if it's behaving the same way. What if we kind of zoom out with a different framing of the question? Unless there's more to say about this, what if we zoom out and say, how do I ask or answer the question, what contracts have been deployed on this account throughout history? So I have an account. I want to know, has this account always had the same contract, or has the contract changed over time? How do I answer something like that?
You cannot do it like in a single call. What I could suggest though is to use this block ID, and instead of querying the latest data of view account, you query certain block height. You essentially have the monotonically increasing block height over the time, and you can start with querying the latest. Check if if
a binary search kind of
use binary search, yes, to identify the certain boundaries.
Yeah, where is the point that it changed? Did it change halfway in the history, or
exactly
upper or lower bounds or whatever, and try and collapse that window? Yeah, I mean, so this would be I think useful for sort of coarse changes, big changes. If the account version, if the contract on an account changed once or twice in history, I might be able to kind of use something like this kind of get blame, approach to trying to figure out where did it change in the block height history. But if it's an account that sort of changes, periodically or just for a moment and changes back, I wouldn't be able to detect this actually very, very well with this approach. I would maybe need like an indexing service, and then I could query, how many times has this changed, or something like that. So we wouldn't be able to query the RPC API. We would need the entire history of the chain, and to be able to query that, maybe using an indexing server, right?
Yeah. So all the data you can see in Explorer is collected throughout the history, querying every single block. Starting from Genesis and recorded in its own database. This is the only way right now, and I guess in the future as well. Near core protocol does not try to come up with all the different sorts of aggregation of data. Instead, it provides a very raw access to certain points in history. If you need to build some high-level view, you essentially are required to build a service that will go through every single block in the history and collect the data that you are interested in. One approach is to use our indexer framework. It's implemented in Rust. It essentially builds on top of the regular near node, and it serves all the data in memory about the historical block information about blocks, chunks, transactions, receipts, and their execution outcomes and changes. So all of that is streamed to you. It's it's up to you. You could use that framework. You could build it on top of JSON RPC using the blocks API and fetching all the data through it. But yes, there is no easy way to navigate the history other than specifying the blockade. So that's the limitation of our near protocol nodes. But as I said, it's a huge scope of work, and you could easily decouple it. That's why we decided to decouple it. And the Indexer framework is just another piece of software, and it's easily integrated. And after that, you are free to do whatever you want with the data and index it in a way that it makes sense to you. So, yeah, that's totally correct. That there is no such method in JSON RPC right now.
Yeah, an aggregate method, you mean? There's no way to do that. You need to use an indexer or something. Yeah, and the indexer framework is pretty straightforward to set up, actually. It's well documented. And there's a couple of examples for the wallet and Explorer already there implemented. And I think Bodan wrote a tutorial that works quite well, actually.